Find the slope-intercept form of the equation of the line described, and then sketch the graph. We have a line described as having a slope of 0 and passing through the point 3, -2. A slope of 0 means that you have a horizontal line. So the moment we plot this point 3, -2, which is over here at your bottom right of your screen, let me shrink this down a little bit. Here we go. All right, so we go to the point 3, -2. A slope of 0 means that your line will go through that point horizontally. It will pass through the y-axis at -2, so that'll help us write the equation of the line. We are given the slope, so we take y equals mx plus b, we replace m with 0. Our x-coordinate is 3, our y-coordinate is -2, so that gives us 2 equals 0 plus b, which is b, and that tells us that our y-intercept is at -2, the point 0, -2. Visually on your graph, you can confirm that. So we take our equation, y equals mx plus b, replace m with 0, b with -2, and you've got the equation x equals -2. In our second example, we have an undefined slope, and the line's supposed to pass through the point -2, 4. Well, let's go to -2, 4. That'll be here in quadrant 2. Undefined slope, we're not going to be able to write an equation in the form y equals mx plus b, and that's okay. With an undefined slope, you can pass any vertical line through this point, -2, 4. I just picked another point. As long as the x-coordinate is -2 and the points you pick, your line will go through those points. Now, this is a special case, and so as long as the x-coordinate's -2, you can pick any ordered pair and it will fall on this vertical line. So that's a special case. The one above is too, horizontal lines and vertical lines. Horizontal lines, you have y equals. For vertical lines, you have x equals. In this example, we have a slope of 1/2, and the line is supposed to pass through the point 8, 4. So if we go through 8, 4, we have to pass through this point. A slope of +1/2 means that every time there's a vertical change of 1 unit, there's a horizontal change of 2. You can backtrack your slope, and there's a clean location where the graph passes through the y-axis. That's at the origin, 0, 0. Now, just to be double sure that 0, 0 is your y-intercept, you can set up the equation y equals mx plus b, replace m with 1/2. Your x-coordinate is 8. Your y-coordinate is 4. Half of 8 is 4. Solving for b, when you subtract 4 from both sides, you get 0. So that tells us that the y-intercept is going to be at y equals 0. When you write your equation, that is y equals 1/2 x plus 0, but you don't have to write the plus 0. Y equals 1/2 x is plenty good, and that's the name of this line. When your slope is -1/2 and you have to pass through the point 8, -6, let's plot 8, -6. That's over here in quadrant 4. A slope of -1/2 tells us that every time there's a vertical drop of 1 unit, there's a horizontal run of 2 units. If you were to repeat this process throughout your line, you could backtrack your line and it has a clean y-intercept at -2. But let's double check. Write your equation y equals mx plus b, replace m with -1/2, x with 8, y with -6. -1/2 times 8 is -4. Solving for b, you add 4 to both sides. -6 plus 4 is -2. And sure enough, that matches what we confirmed in our graph. So the y-intercept occurs at the point 0, -2. Writing our equation in slope-intercept form, we have y equals -1/2 x minus 2. Your slope will be the number attached to x, Your y-intercept will be the number without an x. In our last example, find the slope-intercept form of the equation of the line described as slope of 5/8 going through the point -4, -6. Let's plot -4, -6. That's down here in quadrant 3. A slope of 5/8 says that every time we go up 5 units, we have to run sideways 8. That will take us to the point 4, -1. If we repeat that process up 5 over 8, our next point is 12, 4. Now these are good friendly points. They're not the only points on the line. But when we look at the graph, there's not a clear-cut y-intercept at a whole number. So let's determine what that y-intercept actually is. Set up your equation y equals mx plus b. Replace m with 5/8, x with -4. You can write that as -4 over 1. Y replace with -6. 5/8 times -4. When you reduce your fraction, you get a -5/2. -6 equals -5/2 plus b. Solving for b, you add 5/2 to both sides. So that's where I've got right here. I've added 5/2. I wanted to show you a little trick you can use to change a number into a fraction. Now, since 5/2 has a 2 as a denominator, 2 times -6 is -12. So you can rewrite -6 as -12 over 2. Still has a value of -6, but now it's a fraction with matching denominators. -12 plus 5 is -7 over your common denominator of 2. So your y-intercept is at the point 0, -7/2. Visually, we can confirm that the graph passes through the y-axis at -3.5. So that makes sense. Now we can name our line. That's going to be y equals 5/8 x minus 7/2.